Hi everyone. So today the topic is about information gain, feature selection, principle and impact on decision boundaries, etc. Information gain. Information gain measures how much a, how much the feature reduces uncertainty entropy about the target variable. Formula like Ig of decomposed is equals to h of d minus h of d by a. In simple terms, it tells us which feature is most useful for making decisions, and the role selection in feature select and the role in feature selection is like information gain is widely used for feature selection because it selects the features that reduce uncertainty the most, removes irrelevant or noisy features, helps to reduce dimens- dimensionality, improves model performance and interpretability. Introduction. So, in the field of machine learning, selecting the right features is crucial for building accurate and efficient models. The real world datasets often contain many variables but not all of them, and they contribute meaningfully to predicting the target outcome. This is where feature selection plays an important role. One of the one of the most widely used technique for feature selection is information gain. It is based on the concept of entropy, which measures the uncertainty and randomness in data. Information gain helps to determine how much a particular feature reduces this uncertainty when making predictions. And while making definition and intuition. Information gain is a measure used in machine learning to quantify how much how much a feature reduces the uncertainty of a target variable. It is based on the concept of entropy, which represents the randomness or impurity in the data set. Intuition. The thing means think of information gain as answering this question. And visual intuition like before split mixed data confusion, after good split pure groups clear decisions. And information gain quantities, reduction in entropy with splitting on a feature. Eventually IG prefers attributes that create the purer child nodes, influencing model model capacity to separate classes. Information and bias, limitations and biases. When information gain is the powerful method in machine learning, it has several important limitations and biases that can affect model model performance, like bias towards features with many values. Like information gain tends to favor features with many unique values. Example, ID and timestamps. Such such features may split data perfectly but do not generalize well. Second one, overfitting risk. Selecting features purely based on IG can lead to overfitting. The model may learn noise instead of real patterns. Third one, sensitivity to data distribution. IG depends on probability distribution. Small changes in data can affect entropy and IG values, and this can lead to unstable feature selection. Fifth one, computational cost. For large data sets with many features, entropy calculations become expensive. slow down training, etc. Information gain is simple and effective, but bias is sometimes misleading. It needs to be careful used with pre-processing and validation. The decision boundary impact. In machine learning, a decision boundary is a line, curve, or surface that separates different classes in the feature space. The choice of features, especially those selecting using information gain, has a strong influence on how these boundaries are formed. Like the role of information gain in splitting. Information gain is select features that magnifies a reduction in uncertainty based on entropy. The and second one, effect on shape of decision boundaries. High information gain features like create clear and meaningful splits. Classes become easier to separate. And low information gain features like produce weak or random splits, lead to irregular and complex boundaries. The result, it may get noisy decision regions and increase chances of overfitting. The third one, feature selection and boundary complexity. Feature selection is to be high, fewer splits needed, and simpler boundary. Poor feature selection, many unnecessary splits and complicated boundaries. Information gain directly controls how data is split. Split define the shape and complexity of decision boundaries. Better feature selection is simpler and more accurate models. And practical consideration. When applying information gain in real world machine learning problems, these are several practical factors to keep in mind to ensure reliable and efficient models. The first one, data pre-processing is essential. It handles missing values before computing IG. It encodes categorical variables properly, example label encoding, and normalize or clean noisy data. Poor pre-processing can lead to incorrect entropy calculations. Second one, the discretization of continuous features. IG works best with categorized data. Continuous features must be converted into interval bins. Use equal width binding, equal frequency binding. And bad discretization can reduce accuracy. Third one, handling bias towards multi-valued features. IG prefers features with many unique values, like the solution like use gain ratio to normalize the bias. Fourth one, feature redundancy check. The multiple features may provide similar information. IG does not remove redundancy automatically. It it used to correlation analysis and feature selection techniques, example filtering methods. And information gain is simple and powerful, but requires proper pre-processing, bias handling, and validation. Conclusions. In machine learning, information serves as a fundamental technique for feature selection by measuring how effectively a feature reduces uncertainty using entropy. It helps to identify the most informative attributes, enabling models, especially decision trees, to make accurate and meaningful splits. Throughout the process, information gain plays a key role in shaping decision boundaries, leading to simpler and more interpretable models when relevant features are selected. However, its limitations, such as bias towards multi-valued features and risk of overfitting, highlight the need to careful application and validation. In practice, combining information gain with the proper pre-processing techniques and alternative measures like gain ratio can significantly improve the model performance. Overall, the information gain remains a powerful yet simple tool that, when used thoughtfully, enhances both the efficiency and accuracy of machine learning models. Thank you.